Hello and welcome back to 8-Bit Resurgence. My name's Thomas, and today we're going to talk about reverse engineering. In this world of making and creating things, I thought maybe this would be an interesting topic for you guys to listen to. Really, reverse engineering, there are different ways of looking at it, and depending on who you talk to, you'll likely get a different answer as to what reverse engineering is. Really, it can be broken down probably into three different categories. The first type of reverse engineering that you might come across somebody doing, it's more of an intellectual approach to it. It's an exercise where a board is broken down, and the circuit board is looked at, examined, the components are examined, a schematic is built from that, and then the circuit is analyzed to see how it works, why it works, and possibly even flaws in the design. Then that usually ends up as a document, and then they reassemble the board, and that's the end of the project. All of the types of reverse engineering, they all involve one basic concept, and that is taking an original board and removing all the components, and then moving forward in a direction after that. So the first one was really an intellectual pursuit. The second kind of reverse engineering is where you would still do the same sort of thing. You would take the board apart, make a schematic, but then with that type of reverse engineering that I'm talking about, the person might take the information that they garner from that design and apply that to modern technology, CPLDs, FPGA chips. They might add functionality to it and make it a new device based on an old one. That's another way of looking at reverse engineering. You're still recreating it, but in a different way. And the third kind is one that I have chosen to pursue with my projects. That is to, again, break it down. You remove the components from the board, then you take the board and you make a faithful reproduction. And when I say a faithful reproduction, what I try to do with my boards is I try to make a trace for trace, via for via, identical product. Something that was faithful to the original design. In an ideal situation, if you take a board, or if I take a board that I've produced from an original, and I take the original PCB that I'd stripped down, and I put those together and I hold them up to the light, then I should see light coming through all of the holes in the PCB. So that's usually my ultimate goal. I don't add functionality unless I have a good reason. I try to preserve it as best I can. And really, that's been my goal with my reverse engineering efforts that I've done. I want to produce a board that looks, feels, and functions like an original, so that if somebody else gets one in their hands, when they use it, they install it, it's as if they were using an original and installing an original piece from back in the day when it was produced. It's all, for me, it's all about the experience and preservation. I've personally done quite a few boards. I started doing it around 2017, and I've created a number of them. I've got a few of them set up, and I'm going to show you. Not everyone is the same. Sometimes I make a real accurate reproduction, trace for trace, via for via, that's the ideal. Sometimes I come across boards that have bodge wires and jumpers on it. Never was a finished product, but they put some wires here and there to get it working, and then that's where they stopped. So in that case, I'm not gonna lay up a PCB that has those wires on it. I take it to the next step where I would imagine they would have gone had they done another run. They corrected the traces and then reproduced the board. So that's, I try to do that. Some boards are so old that they were not drawn up with software, they were drawn up by hand. So all the traces are hand drawn. And in that case, that's really difficult to reproduce. Not impossible, but with the methods that I use, it's very difficult. So in that case, a lot of the boards that are like that, the component placement isn't ideal either. So I will, in a situation like that, and I have, moved some components around to where it made more sense, and straightened up the traces, made them a little bit more efficient, and then gone from there. And then the last type of reverse engineering is when the product really was a first run development of a board. They went straight to production with it, and it had flaws. They had jumpers all over it. They didn't place the components properly, and they're soldered in a glom above the board. Something like that I will not reproduce in its original form if I'm going to do a project like that. Cables that are soldered onto the board, I can't bring myself to do that. I have to use like a barrel connector soldered to the board or something like that. So really every project is unique. I have 4 or 5 set up here that I'm going to show you. Each one is somewhat different, from a straight a pure reproduction standpoint, and all the way to where I've done quite a few modifications to it to make it work better than it did originally. So anyway, that's really all I'm going to say about it initially. I am going to next show you some of these boards and a bit of the process. The boards that I have reverse engineered already, I was thinking I would do some separate videos on it, go into more detail. This is just supposed to be an overview video to show you what reverse engineering is to me, and what I've been doing over the years in recreating boards from the past. I have been very fortunate to be able to have found quite a few really rare items. Some of them, as far as I understand and that I've been able to determine, they're one of a kind. The first really rare one that I'll show you is a master adapter, and that was a board that was developed by Schnedler Systems, and it was designed to allow you to connect a GeoRAM or an REU to a TurboMaster CPU and use that in GEOS. That board never actually became a viable product. They closed their doors before they finished it, so that's a really rare one. The Phantom, if you've watched any of my other videos, you've seen the Phantom board that I recreated. I'll show you that. My very first board, the Ice Pick, that was a very interesting project. And I have two other ones. I have a Csi Connect, which was kind of a really unusual product that I'll show a little bit to you about. It allowed you to connect any IEEE device to the IEC serial bus of a 64 without the need of any kind of cartridge IEEE interface, which was quite unique. And then lastly, I'm going to show you the multi-link, and I'm going to do a separate bunch of videos on those. It's quite interesting. That's actually a networking device for the Commodore 64 that I reverse engineered. So let's take a look at some of these, and I'll give you a little bit more insight, just kind of at a high level, what I do when I reverse engineer a component, and then, you know, if I'd like to create some more videos in the future with a little bit more in-depth coverage of these that I've done, and eventually maybe even do reverse engineer something and allow you to follow along the entire process from beginning to end, something new. So let's have a look at some of these boards that I've got to show you, and I'll explain the differences and some of the unique things that I ran into, roadblocks or whatever you want to call them, but interesting situations. All right, let's have a look. All right, this is the Ice Pick cartridge. It was the very first board that I reverse engineered. I had always wanted to do a cartridge and never had done one before. So this was the very first cartridge that I actually built, all the way from taking it apart to getting a finished product. So this is the Ice Pick, not the exact one that I use, but it is an original Ice Pick cartridge. So this is what you would start with if you're going to reverse engineer something. Then you have to do something that might scare a lot of people, and that's strip every part off the board. And this is an original, this is actually the board that I used to reverse engineer it. This is an original Ice Pick board with all the components removed. And you'll look on the back side, I did burn the board. Now, removing components, there are a couple of ways of doing it. You can either cut the components off the board and then remove the pieces one by one, and that's probably, it's the most destructive, but it's the easiest on the PCB. What you have to understand is old PCBs, the traces and the vias, they're not all adhered to the board, especially after all these years, 30 or 40 years or more. They're not stuck to the board as well as you'd say a modern PCB. So when you heat them up, you can end up ripping traces, ripping vias off the board, and that's going to make removing or rebuilding the board after you're done more difficult, as you'll have to run wires and so forth. Can also make it difficult to reverse engineer it if there are traces missing or parts of the board missing that you might overlook in your design. So cutting it off isn't anything that I've ever done. As you can see, I heated the board. There are hot air rework stations, there's solder vacuums, there's solder wick. There are lots of different ways of doing it. In this particular board was the first time I used a hot air rework station. As you can see, I burned the board. It wasn't too bad. You know, it's discolored, but I didn't heat it to the point where I bubbled up and really destroyed the substrate of the board. So that really takes a lot of skill to take components off, and especially on the ones that have weak traces or weak vias, they're really easy to rip off the board. So really it's practice that makes the difference. You know, before you start on any kind of project like that, you really do need to practice on old scrap PCBs, removing components. And when you're comfortable removing components, then move on to something. And if you're gonna ever do this yourself, pick something that isn't too expensive, and that you can maybe have a couple of. I always try to have at least one original and one that I can tear apart, and then this one would be the reference for when I reproduce it. So this is an original, also an original. I have lots of ice pick cartridges, as you can see. This here on the left is an original ice pick board with the original components on it. This is the one that I removed. I was fortunate enough to get this particular one. It had one of the fingers on the card edge was worn off, so it didn't actually work. You had to really fiddle to get it to make contact properly, so I never ended up putting it back together because it didn't really work anymore anyway. But I still had an original to reference. And there's the back. Oh, that was the back. Anyway, so this was so that's where I started. From here, I translated all the traces into some software. I used Eagle to lay up the board. It was, again, with this board, it was the very first time I ever laid up a board, so it was certainly took me a lot longer than it does today. It was quite a steep learning curve, I have to say. But I got it done, and this is the prototype. So this is the very first ice pick cartridge that I had built myself. I laid up the PCB, got the components. It's all socketed. My very first boards I always do are all socketed, just so that I can remove components if something doesn't work. It just makes troubleshooting a little bit easier. So this is, I used Oshpark for these boards. It was the first time I ran boards, so they were the first people I came across. I stopped using Oshpark, had some trouble with quality with them. I've since moved on to other places, ended up with at PCB Way. They make really high quality PCBs. Very happy with the service and the product that they produce. So I use them now, but in this case this was an Oshpark PCB. I don't know if you can see it, but it's one of the purple boards, and it didn't work. Now the reason why it didn't work was related to the components. These ones here. These four were Fairchild ICs, and I used TI, Texas Instrument ICs, as replacements, same values, and put them in, and the board didn't work. And as I learned, again, a lot of this I learned through trial and error, you really have to, if you can't get the original components, which a lot of the times you can't. You know, Fairchild hasn't made components for a very long time, so you're going to have to find suitable replacements. But those replacements really need to electrically match the original. So you have to hunt down the data sheets for all of these chips, and then you have to find the data sheets for the old ones and the new ones, and then you have to compare, and you have to try to get chips that match the characteristics. When I first built this one, the problem was the Ti chips were slower than the Fairchild chips. Not by a lot, but a little bit. And that was enough to throw this whole board off so that it wouldn't work reliably. So that's something to look at, and something that you don't have to learn through trial and error. You have to match the components from the old board to the new one, so you have a good chance of having it work. So once I got that work, I believe there was a trace error on that board as well, which can happen in laying it out, especially since I did tear off one of the traces on the original board. Again, I was new, so I hadn't done many of those before. So this was the final PCB that I produced for this. Chose to do it in black. Thought black and gold would look nice. If I were to do it again now, I'd probably pick green just because it's more reminiscent of the original board. My ideals changed a little bit over time. And this is a finished reproduction of the original board. So here you can see, this is what I would call a faithful reproduction. It is dimensionally identical to the board. The switch is in the same spot, the mounting holes are in the same spot. This cartridge that I reproduced will actually fit in the original case, which was one thing that I wanted to be able to do. Because I came across this board that was bad, I thought, well, what if somebody else had an ice pick that didn't work anymore and they wanted to put a replacement in. So I made this so that it would fit in the original case. So this is the first board I reverse engineered, and I would call this one a pure faithful reproduction. It is a trace for trace, via for via, identical reproduction of the original board. The fingers are a little bit longer, but I did that for a reason as well. I wanted them to be a little bit deeper, but otherwise it's exactly the same. The positioning of the text is all the same. One thing I will do on these is I want to always make sure that my reproductions aren't mistaken as an original, so I always put my information on here. I've done all these under the name Core i64, and I put the year. This was done in 2017, and I also put this on here that it was recreated with permission, and it was recreated by permission. I had a nice long chat with Chip Gracie, the original designer of this, and he did give me permission to do this. So that was really quite exciting to be able to speak with him. So this is what I would call a faithful reproduction, as I said. So the next one I'm going to do is, well, you'll see in a moment. Okay, this one is the master adapter for the Turbo Master. I don't have the original anymore to compare the original to the reproduction because it was loaned to me, and I've returned it since. But this was one of the boards that again, it is a faithful reproduction. However, it did have some bodge wires right around here, this part of the board, there were some traces cut and some wires soldered in place from the original designer. I chose, when I reproduced this, to not put the bodge wires. Obviously, I wanted to incorporate those changes into the PCB. Otherwise, this is an exact facsimile of the original. This is actually the prototype, the very first one that I built. I always try to build the first ones in a different color, just so I can tell the difference. As you can see, there were some trace errors there, and there. And then on the bottom, there's also trace error here. I think there were a couple. One under the chip. There were a few. But it's built exactly the same way. It has the exact same connector I managed to find to connect this part that plugs into the 64, and it attaches to the board vertically so that you can plug in your GeoRAM or REU and your TurboMaster, and it really depends on what you're using. If you're going to be using GeoRAM, then the TurboMaster is plugged in here. If you're using an REU, the TurboMaster is plugged in here. So, and then the jumpers change as a result. In doing this, I was fortunate enough to find the original driver disc that came with this, as well as the documentation. So it really ended up being a complete package, and I was very happy with it. This is what the first run of the PCBs looked like. Again, blue. You saw it over on this one here, where I had built it already. And then this is the finished one, with all the corrections on the board, and it still plugs in the same way, like that, and then plugs together again. And these are the PCBs. So the original had the same pattern on the sides, and it had some text here and some text here. So I put my own text in here. It says Schnedler Systems Master Adapter. The version that I built it was Rev A was the original board. I put a little plus there just because I had made the corrections over here that they had planned on doing on their final PCB. And the date that I made this, I did this in December 2019. So this is what I would call again a faithful reproduction of the original. However, it does have some corrections built into the board that weren't on the original. I don't think that it takes anything away from anything, but that's the finished product there. So the next one we're going to look at is going to go back to a faithful reproduction, even more so than the original Ice Pick cartridge. So we'll do that one next. Alright, this is what I would class as the most faithful reproduction I've done. This one is one of those boards that you can hold up the original and the reproduction with no components on it, and all the holes line up. The traces are all in the exact same location. It is dimensionally identical to the original. This one I left the socket off. I wasn't going to use it, but otherwise, I mean, you could add the socket and it would be the same. What I did leave off are these are test point locations. I didn't want people plugging in things in there that they shouldn't be, so I left them off, but it could certainly be added again to make it even more authentic. This is the original here, and here is the reproduction. It is the same. It is the same traces, the same vias. I managed to find all the right components, and it works exactly like the original does. However, when I first made one. Again, a blue one because that was my prototype. And this is the very first Phantom that I created. And at the time I didn't realize that these test points weren't needed, so they're soldered on there as well. But it does have some errors. I think there were 5 or 6 errors on this board that I had to follow through and correct. And that's something that you would come across if you do any kind of reverse engineering yourself. You're going to inevitably have trace errors on your boards. No matter how careful you are, something will go wrong. And it has on all but one of my boards. The last board that I did, I actually everything was correct on that one, so I was quite surprised. Maybe I'm getting a little bit better at this as time goes by. But yeah, so this is what I would call a completely faithful reproduction. If you look at this one, the original, this one is the reproduction. They really do look very much the same. The PCB manufacturing process is different. On this one I flow a ground plane, whereas this one didn't have that. So the PCB manufacturing process is different, and that ends up giving you a slightly different look than the original, but I tried to maintain the green, trace locations, component locations, everything was exact. And this one I was very careful. I used a caliper to locate every single via and every pin on this board because I wanted this to be exactly the same. So I was very pleased with how that turned out. Now I'll move on to the next one, which isn't quite exact, and I'll be able to show you why. Before we move on to the next one, I had forgotten that I wanted to show you this. Some boards, in building them, can be very time consuming. The Phantom board is a very time consuming board to build. Pin alignment, because it connects to so many places on the 1541, it's really crucial that you get the components that connect to the logic board of the 1541 in exactly the right place. And I found the only way to do that was to build a jig. So again, this is also part of the reverse engineering process in building a reproduction. You might have to build a jig. And this is the jig that I built that allow me to construct a working Phantom that will fit like it was poured into your 1541. Everything, I use machine sockets to align the pins perfectly so there's no slop. So if I build a Phantom, I build it on this and everything is perfectly aligned. And I just constructed it out of one of the prototype boards that don't work anyway without any changes. And when I order boards, you have to order 5 at a time. So I had some spares and I used it for a jig. So this is something that you might come across in reverse engineering, the need for a jig. This is what a jig would look like that you would use to construct a more complex board that has a lot of connection points to the destination device. So this is the second last device that I'm going to show you. This is the Csi Connect Model 400. This is a device that you would connect your IEEE device to here, and then you would connect your IEC serial cable to this point here, and you'd plug it in and you'd be able to access your 4040, 8050, 2031, SFD, whatever your old PET drive you could access it natively on your 64, and the speed is actually not bad. People have commented in the past that, oh, well, why would you want to do that, because you don't take advantage of the speed, the parallel speed of an IEEE drive, and that is true. You don't get that speed, but you do have the convenience of being able to access the drives simply through an IEEE bus alongside your 1541, 1581, whatever else you happen to have connected to it. So that's really the usefulness of this board. Now, as you can see here, these traces don't go straight. They go all over the place. They weave in and out. They're all hand drawn. This is a very old board, and some of the component placement not the greatest. For example, this crystal here doesn't fit properly. There are a few components and capacitors and such where they didn't really fit on the board properly, because the hole placement for those components to solder into the board weren't correct. So this is a board that I recreated, but I took a few liberties in changing it. For a few things I changed. These components here, they were a bit too close to the edge, and the placement of the traces was poor. And the whole layout for the components was also not good. So I moved them inward into the board. As you can see here, power supply soldered onto the board. I'm not a fan of that at all. I think that's cheap. And I can see there was a cheap way of doing it, not something that I would do on a reproduction. So that I would choose to change that as well. You'll see this IEEE connector is not keyed, so it would not work with Commodore, authentic Commodore IEEE cables. You'd have to pull out those little dividers in it if you wanted to use one of those cables. And really this connector should have been keyed, so that's also something that I would consider changing. So in reproducing this board, I wouldn't call it a faithful reproduction. I'd call it a respectful reproduction that I did. So I'm going to show you the first PCB that I created. So this is the first one. Again, blue. You can tell is the first one that I did. It looks very similar to the original. It's got this grounding point here for the regulator. Everything else is placed where it was originally, and because this board had hand-drawn traces, I found it for myself rather difficult to reproduce. So what I did in my first run is I actually made a reproduction exactly with the components. Everything is in the exact same place. This board did work fine, but it's not the way I wanted it on the final board. So I went from that board to this one, which is the final one. As you can see, I keyed the IEEE connector. I did move, I left some of the resistors here, but I did move the capacitor, resistor, diode. I moved a couple of components to the back here. Moved the crystal over here, a bit out of the way. Now, there was a version 400S, Model 400S, that came out shortly after the 400, and it was essentially the exact same board as this, except they had cut a trace and put a switch on it. And that switch allowed you to turn the IEEE functionality on and off, and turn the serial, the IEC port for connecting, passing through IEC signals from another drive, turn that on and off. I decided to take my 400 and turn it into a 400S by adding those functions. And what I did was I added those connection points here to the board. Again, they just soldered the wires on wherever. They had a number of different versions of this board, 425, 400, 400S. They all had the exact same PCB with minor changes. The 425S had an LED on it, the 400S had the switch, and the 400 was just plug in, turns on, that's it. So I took all of those features from the 400, the 400S, and the 425, and I incorporated them all onto this board with a few of my own changes. Like I said, I moved these components in and out of the way. I routed the connection point so that you could have jumpers or run a switch to it. And I put some LEDs on the board here. There are a couple of surface mounted LEDs. And I also put a barrel connector in here so that you can plug an adapter on. As it turns out, the circuit, the power circuit on here is rather good. The regulator that they're using allows an input voltage of 7.5 volts to 25 volts and brings whatever you happen to be putting in down to the appropriate voltage for this board. So really you can take any adapter you have laying around, plug it in, and this thing will work. It works very well. Very pleased with how this turned out. This isn't a trace for trace via reproduction, but it looks good and it works well, and it incorporates all the features of the 3 different variants that I've been able to come across anyway. Makes a very tidy package, works well, and was a fun project. So this is the second last one that I want to show you. And the last one is going to be one step further away from original, and I'll show you that next. Alright, so this is the last one that I'm going to show you, and I'm showing you this one because it is the most different from a factory cartridge or a factory reverse engineering project that you could do. So what you're seeing here is this is an original multi-link satellite cartridge. It has the link wires that the sync wires that used to have to plug onto the board, clip onto the board, and this is the network cable, and this is the cartridge. Now without the case on it, this is what it looks like. Now there are a number of variations of this that I came across. You can see these resistors are kind of just soldered together here and attached. These are the jumpers for configuring the satellite number. Those are very confusing to figure out what satellite number you want to program this for. And the network cable is permanently affixed to the board. This one is non-functional. There are some bodge wires that need to be on here as well to make it work that are missing. So this is a cartridge that wasn't, I would say it's not complete from the factory. It needed quite a few changes. This is the master cartridge, and there are again a number of soldered wires on here that allow it to work, and if they're not there, it doesn't work. So here is an example of the board once it's stripped down. so I could see where all the traces went. But I also took particular care in noting all of the corrective wires that they had soldered on in order to make sure it worked. What I ended up with was this board. This was my reproduction, and if I'll bring the original one back, and you'll see there are some differences. For example, where the network cable soldered on, that's straight pins now. Here is a jumper block, whereas this is just where wires were soldered on. And then I have a number of places where solder pads can be jumpered in order to configure this one board to do many functions. They had in the mini master, the master cartridge, it was a different, wired quite rather differently from the satellite cartridge. I didn't want to produce many boards. I just wanted to have a single board, so I incorporated all of the changes for that, for the master, the satellite, and in the end I also put in the changes that needed to be there for getting it to work on a 128. So as you can see, this board, the reproduction is quite different. A lot of the traces are similar, but the wiring overall is rather different to produce something that looks very, very much the same physically, but it's certainly wired up differently. So here's the finished board that I ran in gold, and here is the bare PCB that I start with. So as you can see, the straight pins are on here for connecting the network cable. The jumper block, very easy to configure. The satellite number for each cartridge was very important for me to make that easy to do. And you can see the resistors are soldered on nice and tidy, whereas if we look at the original, it's not quite as tidy. So then I took it one step further, as I did with some of the other boards. I just haven't shown you because I'm trying to keep this as short as possible. But this is the original board, and this is the reproduction that I came up with. So I designed a case that looks exactly like the original. It has the same profile. It's an amp case. I reproduced the label so it looked reminiscent of the original. However, you see this cable is attached. This one is not. You just take that cable and it just plugs in. It's a keyed slot in the opening in the case. You plug it in and off you go. Need a little spool to hold the cable, and the jumpers are accessible from the outside, so you could reconfigure it to a different satellite number. However, then the number on the case wouldn't match, but it just made for ease of configuring. So in this particular case, I did reproduce it. I did reverse engineer this cartridge. However, I made the reproduction had multi-purposes. It still looked the same. However, it could be assembled to provide different functionality. It could be a 128 cartridge. It could be a regular 64 cartridge. The original would only work on a long board, whereas this will work on any 64, Ultimate 64, 64 Reloaded, and then a 128 version as well. So I did make changes. So this, in the end, this is a reverse engineering project, of the original board. However, there are a lot of changes I put into it. So I hope you found this interesting. I wanted to just start off with a short video. I know this probably isn't going to end up being a very short video, but I wanted to highlight the different types of reverse engineering that can be done, and specifically the kind that I do. I think it's also important to see that there are differences that happen when you're reverse engineering, and every product that you you work on, every project is going to be slightly different. You know, if you found, as you saw on the Csi Connect, hand-drawn boards, the way we make PCBs nowadays, we use software, and although you could draw them like they were hand-drawn, that's not really the preferred way of doing it, and it's not the way I learned and taught myself to do it. So you end up changing the board or the way the reproduction looks as a result of that. If there are bodge wires on the board that are needed to make it work, you'll want to incorporate those into the design. At least I do, maybe you don't. There are times when you would accurately reproduce it to the finest detail, like I did with the Phantom. That particular project, it was very important to me that I reproduce it exactly the way it was, and I'm happy with how that turned out. And then the multi-link, well, I was thrilled to have been able to get my hands on that. It's such a rare piece. I don't really know of, I know of one system that exists in the world, but it's a master board and a single cartridge. So I was very lucky to get my hands on that, but that one really needed a lot of work. And what I ended up with is really a very useful product, very functional board, that it behaves, it plugs in, and it behaves exactly like it did back in the early 80s when it was made. But I expanded the functionality of that particular one to work on a wider range of machines than it was originally designed. I mean, that particular one, for example, the 128 didn't even exist when that thing was made. So that I managed to get it to work on a 128, I was very happy about that. And that I was able to eliminate these sync wires, so that because they're a pain to have to open up your machine, hook them on. If I could get away with not having to do that, that's always preferred. So having a simple cartridge that plugs in my view, is something that's better than the original, but I don't feel that takes anything away from it. So that's really my overview on reverse engineering. There are a lot of things that you know, it's a lot deeper. It's a bigger topic than simply this introduction. I wanted to discuss the types and show you some examples of what I've done. But if there's some interest, maybe I'll make another video, go a little bit deeper, and discuss the skills that you need, and perhaps demonstrate some of the skills that you can maybe learn from if you'd like to do a project like this yourself. So I guess that's about it for now. I do appreciate you sitting through this entire video. I haven't looked at how long it's going to be, but my throat's dry and I'm pretty much done talking now. So thanks for coming back to the channel. I would appreciate it if you subscribed. I have a lot of ideas and big plans for videos that I'm going to produce on this channel. Hope you guys all have a great new year, being the first video of 2022. Like it if you like it. Down thumbs it if you don't. Take care, and I'll see you next time. Bye.